What makes BB84 and E91 unique for quantum cryptography? Imagine a secret message that can never be read by anyone else, no matter how clever their hacking tools are. That's the promise of quantum cryptography, and today we're exploring what makes two key methods stand out. First up is the BB84 protocol, created in 1984. It uses tiny particles called photons to send bits of a secret key. These photons are polarized in different directions, like tiny arrows pointing in specific ways. The sender, often called Alice, randomly chooses how to encode each photon, and the receiver, Bob, randomly chooses how to measure them. Because of a rule in quantum physics called the no-cloning theorem, anyone trying to eavesdrop cannot copy the photons without changing them. If they try, it causes errors that Alice and Bob can detect. After the exchange, they compare which bases they used over a public channel and keep only the bits where their choices matched. This process makes the key secure because any interference by an outsider would be obvious. BB84 is simple and widely used because it only needs single photons and basic equipment. Now, let's look at the E91 protocol, developed by Arthur Eckert in 1991. Instead of sending individual photons, it uses pairs of entangled photons. These photons are linked in a way that measuring one instantly tells you about the other, no matter how far apart they are. This strange connection is called quantum entanglement. When Alice and Bob measure their photons, their results show correlations that violate Bell's inequalities, a fundamental test that proves these particles are truly entangled. If an eavesdropper tries to listen in, the entanglement gets disturbed, and the correlations weaken. This makes it easy to spot any intrusion. E91's security relies on the non-local nature of entanglement, which is a different approach from BB84's measurement disturbance. It also opens doors to device-independent security, meaning the system can be secure even if the devices are not fully trusted. So, what makes these two protocols special? BB84 is all about using the disturbance caused by measurement to keep secrets safe. It's straightforward, effective, and easy to implement with current technology. E91, on the other hand, uses the strange, non-intuitive property of entanglement to guarantee security. It can be more robust against certain attacks and is a step toward more advanced quantum networks. Both are vital in the emerging field of quantum communication, helping us move toward unhackable messaging and ultra-secure data sharing. They show how the weird rules of quantum physics can be turned into powerful tools for keeping information safe.